Let's go to page 225. This is lesson 4.2, and this lesson is to apply congruence and triangles. Okay. So two geometric figures are congruent if they have exactly the same size and same shape. So imagine cutting out one of the congruent figures. You could then position the cut out figure so that it fits perfectly onto the other figure. So here's an example of congruent. So it doesn't matter which way you rotate. Okay, you can even flip it over. As long as they have the same size and same shape, then they are congruent. Here's an example of not congruent. Okay, so these two are same shape, but different size. So again, when you have different size or different shape, then it's not congruent. So to be congruent, they have to be exactly the same size and the same shape. So that means you can be able to map one above the other. Okay. So in two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. Corresponding part means the matching part. Okay. So like this one over here, see, this and this and this, they are congruent parts. This, and these are the congruent parts, corresponding parts. Okay. So in congruent polygons, this means that the corresponding size and the corresponding angles are congruent. Okay. So again, corresponding means the exact same position, the same location. Okay. Okay. So congruent statements. When you write a congruence statements for two polygons, always list the corresponding vertices in the same order. You can write congruent statement in more than one way. Two possible congruent statement for the triangles at right are triangle ABC is congruent to triangle FED. Okay. Now, again, you can write in any order you want, but you must be very careful. The letter must match exactly. Okay. Notice over here you got angle A is the single arc, right? Angle F is a single arc. That means no matter how you write it, the A must match with F. So over here, A is in the beginning, so F must be in the beginning. Over here, A is in the end, so F must be on the end also. Over here, you see the angle B. See, they have two arcs. These have two arcs, right? So it tells you that angle B and angle E are congruent. So when you're writing the congruence, make sure they have to match. Notice the B is in the middle, so E must be in the middle. Over here, B is in the beginning, so E must be in the beginning. Okay, so you cannot mix them. Okay, so when you label them, you have to match them up carefully. Okay. Next one, angle C. So angle C has three arcs, right? Angle D has three arcs. So when you write, C is on the end, so D must be on the end. Over here, the C is in the middle, so D must be in the middle. Okay. So when you write, the easiest thing to do is just go, like one arc, two arcs, three arcs. So I would go A, B, C. So you can go one arc, two arcs, three arcs. Okay, that would be probably the least confusing way. Okay, and corresponding angles, again, angle 1 is, so we already did the congruence already. Now corresponding sides, you look at the hash marks. So you use a hash mark for the congruent side. See, one hash, so that means this means AB and EF are congruent. Okay, so AB and FE are congruent. Then if you see the two hash marks, so AC and FD are congruent. And the three hash mark means BC and ED are congruent. Okay, so make sure when you're doing the proof, right, or whatever you do with geometry, make sure you pay attention to the markings. That way, you know exactly which is congruent to which, so you don't get all confused. Okay, so again, it's very important to pay attention to the hash marks and the arcs. Okay, okay. So let's go to example 1. It said write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Okay, okay. So first you do the whole triangle. So triangle JKL is congruent to what? Okay, so notice J is a three arcs, so it must match with letter T. So you have to start with T. So again, J match with T. And K is the one with the one arc. Okay, so you have to match with S. So K must match with S. And then after that, L is 2 arcs, so match with R. Okay? So first you write the congruence for the whole triangle. Then after that, you write the congruence for the angles. So angle J, the angle J is congruent to angle T, right? Because they have 3 arcs. See the marking? And angle K, the 1 arc, it match with angle S. And angle L, the 2 arcs, it match with angle R, the 2 arcs. Then after you can do the sign. So JK is congruent to, now pay attention to the letters, okay? JK is a 1 hash mark, but JK is from the 3 arcs to 1 arc. So you want to go from 3 arcs to 1 arc, so it'd be TS. Okay, so JK is congruent to TS. Now next you go KL. So KL is a 2 hash mark, so you have to match with this side. But again, watch the order. KL, it go from 1 arc to 2 arcs. So you want to go from 1 arc to 2 arcs, so it would be SR. Okay, so again, you have to watch how you match things up. Everything has to match correctly. So next, you're going to do LJ. Okay, LJ is a 3 hash mark, so it match with this side over here. But LJ, it goes from the angle with the 2 arcs. So you go from 2 arcs to 3 arcs. So you have to go from 2 arcs to 3 arcs. So it would be RT. Okay? So that's how you do the congruence. So pay close attention to match everything exactly. Okay, let's go to example 2. Use property of congruent figures. So in the diagram, so this is given, so this is congruent to this. So the two are congruent. Find the value of x. So you're looking for value of x. Okay, now, so this, so you kind of have to look, okay, so this angle is congruent to this angle, right? Again, just by just, check, right? So this angle is congruent to that, so you set it to each other and you solve. Okay, you know that the FG, so you know the FG, right over here, so FG is congruent to QR, because from this it tells you which is which, right? Okay, so for example, Q, see the Q, it match with F. See that Q match with F. So that's how you know that this Q match with this angle. Okay, so that's one equation. Okay, and also you can so over here FG, right over here. So FG, it match with QR. Again, from here, that's how you know. Right, FG, see FG, the last 2 letters. So FG match with QR. So FG match with QR. So you set it equal to each other. So FG is 12. Right? So you substitute, FG is 12. QR is 2x minus 4. Okay? So from here, you plus 4 on each side. And then from here, you divide by 2. So x equal to 8. Okay? Once you find x equal to 8, so now you can find y. To find y, again, you can use angle Q. See angle Q. The Q match with F. So angle Q will equal to angle F. Right? So angle Q equal to, is congruent to angle F. Okay, so the measurement will be equal. So that means 60A, so that's this over here, that's the measure of angle F, will equal to 6y plus x. Okay? And we know from here x equal to 8, so you substitute 8 into the x. And from here you minus 8 on both sides, so you got 60 equal to 6y. Divide both sides by 6, you get y equal to 10. Right? And that's how you do it. So the key is, when they're giving, you have to know how to match things exactly. Okay, so that way you know which is congruent to which. Okay, example 3, it shows that figures are congruent. So this is giving, again, pay attention to the hash marks, right? Okay. So it says, if you divide the wall into orange and blue sections, okay, so orange and blue sections along the JK, line JK, where the section of the wall be the same size and shape, explain. Well, the answer is yes, because if you notice, everything all match, right? So this is congruent to this is congruent to that, this is congruent to that. So when, and this is congruent to itself, right? So when every side has a matching side, therefore they are exactly same shape and same size. Okay. So again, solution, you can go through that, right? So again, everything all match. Okay. Okay, let's go to theorem 4.3. Okay, the third angle theorem. So the theorem says if two angles of one triangle are congruent to two angles of another angle, then the third angles are also congruent. What it's saying is that if you have two pairs of congruent angles, right, two pairs, so this is one pair, two pair, okay? So if you have two sets of congruent angles, then the third one will also congruent, okay? And again, this can, do the proof on exercise 20 on page 230, okay? Okay. Let's go to example 4. Use the third angle theorem. It says find the measure of angle BDC. So BDC. So you're looking for this angle right over here. Okay. Okay. So if you notice that, so over here solution says angle A is congruent to angle B by the hash mark. See that? By the arc. So this angle is congruent to this. Okay. So sometimes if it's very confusing when you have overlap, some people have a hard time. So I would suggest this is what you guys would do. Okay, separate the two triangles. So you're gonna have a triangle like this, and just undo the two triangles. Okay, so you got A and C, D, and this would be C, D, B. Okay, so go and undo the two triangles. So you can see that from here, so you can see that that these two are matching and these two are matching. So that means angle D and angle C will be congruent. Okay. So this is 45 degrees, and this is 30 degrees. So if it's 30, this would be 30, and this would be 45. So you can use 180 minus these two. So 180 minus 30 give you 150. 150 minus 45 give you 105. And therefore this would be 105. Okay? So when you're overlapping, again, sometimes it's very confusing for the students. So what you do, you slide one of the triangle over to separate the two triangles, and it becomes more obvious. Okay? Okay. So write approve. So again, this is all giving, and the giving is all indicated over here. So you want to prove that the triangles are congruent. Okay. So again, if you have a hard time visualize this, sometimes you might want to redraw this and separate the two triangles if you have to. So this is A, C, D, one hash, one arc, two hash, two arcs. Okay? So you might want to separate the two triangles. Okay? Okay. So since this is AC, so this will congruent to each other, right? Right, because something is something equal to itself, right? Okay. So this is your reflexive property, right? Reflexive property we're going to talk about in the next page. But anyway, so first you do all the markings, right? So again, AD congruent to CB, DC is congruent to AB or BA, okay? So all these are given, right? And then you can see that AC is congruent to AC, and that's your reflexive property, okay? So once, and also you have the angles, okay? So this angle is congruent to that, this angle is congruent to that. By using the third angle theorem, that means this will congruent to these, okay? So angle D will congruent to angle B, okay? And then after that, you can say that triangle are congruent. That's a definition of congruent figures. because all three sides are congruent to each other, all three angles are congruent to each other, means they have the angle will give you the same shape and the length will give you the size. Okay, so by all three angles are congruent, that means they are same shape, and all three sides are equal, congruent, means they are same shape. So if they are same size and same shape, means they are congruent. Okay. Okay. Okay, so let's go to page 228. Property of congruent triangles. The properties of congruence that are true for segment and angle are also true for triangles. Again, we will cover all these for the segment, for the angle. Now it's going to be same for triangle. So property of congruent triangles. The reflexive property of congruent triangles. So triangle ABC is congruent to triangle ABC, means triangle will equal to itself. Okay. The next one, symmetric property of congruent triangles. So if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So you just kind of flip it over, right? So that's a symmetric. Okay. The one we're going to use a lot, okay? So this one we're going to be used a lot, okay? And this one also used a lot. This one is used in this kind of situation that when you separate and you got AC is congruent to AC. Okay, when you separate the two, so you still have the AC equal congruent to AC. Okay, so this is when you're going to use this in this situation. Okay. Another one that you're going to use a lot is this one, the transitive. So if triangle ABC is congruent to triangle DEF and DEF is congruent to triangle JKL, then triangle ABC will be congruent to triangle JKL. Okay. So again, if the first equal to second, second is equal to third, then first equal to third, right? So we cover that for the segment and angles. So remember these three, right? Reflexive, symmetric, transitive.